Hello, Mr. Collier here. Today I'm going to give some notes on Newton's three laws of motion, and this goes with Chapter 6 in your textbook. I'm going to give all these notes at once, but if you want to break it down and just do the parts one at a time, that's fine as well. So, Isaac Newton was a scientist who lived in the 1600s in England. He really contributed a lot to science, and he's, for good reason, one of the most famous scientists of all time. He's most famous for his three laws of motion, which is going to be the focus of our discussion today, but he also did his universal law of gravitation, which we talked about in Chapter 5, and he invented a reflecting telescope, kind of co-invented calculus, and very impressive individual. First, I want to review some topics that go back to Chapter 5. So we defined a force as a push or a pull, any action that has the ability to change motion of an object. In other words, it can cause acceleration to happen. The metric unit for force is the Newton, which is the amount of force it takes to accelerate a 1 kilogram object at 1 meter per second squared. I also want to review real quick from Chapter 5 the difference between mass and weight. Mass is the amount of matter that an object is made of, and it's measured in grams or kilograms. Weight is the amount of force that an object exerts because of the mass it has and the gravity acting on it, and that's going to be measured in newtons. The last thing I want to review from Chapter 5 is the difference between a balanced and an unbalanced force. The motion of objects, and that's going to be what we're talking about with Newton's laws, depends on the total of all the forces acting on an object. We call that the net force, and just a reminder for how to do it, you're going to add forces acting in the same direction, subtract when they're in the opposite direction. So here's an example of a balanced and unbalanced force. These forces are balanced. Another word for that is equilibrium, and when an object is in equilibrium, it will not accelerate. Here we have unbalanced forces. Force A is much bigger than B, so it will overpower it. You would subtract those two forces, and when forces are unbalanced, there will be acceleration in the direction of the net force.